All right, today we're going to talk about one of the absolute cornerstones of the metal world, shielded metal arc welding. You probably know it by its more common name, stick welding. And we are going to break down exactly how this incredible and incredibly useful process actually works.
I mean, come on. You've seen this image 1,000 times, right? That brilliant flash of light, the shower of sparks. It's iconic. But what is really going on inside that intense arc of energy? How does a simple coated rod fuse two solid pieces of steel into one? Well, let's get into it.
So here's the official definition. At its very core, SMAW, shielded metal arc welding, is all about using electricity to create an arc that is so incredibly hot it literally melts metal. All you really need are three things: a power source, the metal you're working on, and this very special tool called a covered electrode. Yep, that's the stick in stick welding.
Okay, here's what we've got on tap. We'll start with the basics of what stick welding is. Then, we'll get into the real heart of it, that all-important electrode, and figure out what all those numbers mean. After that, we'll talk about the skill it takes to control the arc, and finally, what it takes to lay down a perfect weld. So, first up, what exactly is stick welding? You know, this process has been around for over 100 years, and it's still called the workhorse of the welding world. Why is that?
Well, the popularity really comes down to two things. It's simple and it's tough. The equipment you need is pretty basic. It's not super expensive, and you can take it pretty much anywhere. It's also incredibly robust. Because the process kind of creates its own little protective atmosphere, you can use it outside in the wind, which is a huge deal. That's why you see it everywhere. On construction sites, out on pipelines, you can use it in tight spots and weld a ton of different metals. It's just so versatile.
Okay, now let's zoom in on the real star of the show, the electrode. This thing is so much more than just a piece of wire. It's actually a brilliantly designed all-in-one tool that makes this whole process work. So if you look here, you can see every electrode is made of two main parts. On the inside, you've got the metal core wire. That's what carries the electricity, and it also melts to become the filler metal that builds up the weld. But the real magic, the secret sauce, is that stuff on the outside. That's called the flux covering.
So, what's so amazing about this flux covering? Well, it does three critical jobs all at the same time. Job number one, it creates a shield. When that flux gets superheated by the arc, it basically burns and releases a gas. This gas forms a protective bubble around the molten weld, shielding it from the oxygen and nitrogen in the air, which would totally ruin the weld if they got in.
Its second job is to act as a flux. Think of it like a cleaning agent. The covering is packed with ingredients that literally pull impurities out of the molten metal, cleaning it up while the joint is being formed. This is absolutely essential for getting a strong, solid weld.
In its third and final trick, as all those cleaning agents do their work, they float up to the surface and form a hardened layer called slag. This slag acts like a protective blanket over the hot weld, letting it cool down nice and slow and protecting it from the air. Once it's cool, the welder just comes back and chips it right off.
Okay, so we know what the electrode does, but how does a welder pick the right one? There are so many. Well, it turns out there's a secret language printed right on the side of every single rod.
Let's take a look at a super common one, E6010. Now, if you've never seen this before, it's just a random jumble of letters and numbers. But for a welder, that code tells them literally everything they need to know to use that electrode correctly.
And the best part is, it's actually pretty easy to crack the code once you see it broken down. The E is easy. It just stands for electrode. The first two numbers, 60, tell you its tensile strength in thousands of pounds per square inch. So this one is rated for at least 60,000 psi. That third number, the 1, tells you which positions you can weld in. A 1 means all positions: flat, horizontal, vertical, even upside down. And those last two digits together, the 10, tell you all about the flux coding and what kind of electric current to use. It's like a tiny instruction manual baked right into the name.
And this system works for all kinds of different materials. You might see an E70 series electrode, which is just for stronger steel. For stainless, you'll see something like E308, where the number matches the type of stainless alloy. And for really exotic stuff like nickel alloys, the letters even give it away. ENICRFE is literally telling you it's for nickel, chromium, iron. Pretty cool, right?
So you've got the right electrode, you're ready to go. Now comes the hard part. This isn't some automated robot process. Stick welding is a purely manual skill, and a good weld depends completely on the welder's ability to control that electric arc.
A welder is basically performing a constant balancing act between three things. First, there's the current, the amperage. Think of it as the heat knob. Too cold and you won't get good fusion. Too hot and you'll just burn a hole in the metal. Second is arc length.
that tiny gap between the tip of the electrode and the workpiece. You have to keep it perfectly consistent. And third is your travel speed, how fast you're moving down the joint.
And this image shows you exactly what happens when that balancing act goes wrong. Each one of these weld beads was made by messing up just one of those three things. You can see how some are all piled up, some are way too thin and weak, some are just ugly. The true skill of a welder is in harmonizing all three of those controls to lay down a weld bead that is perfectly uniform and strong.
Which leads us right into our final topic. With all this technique and science, what's the end goal? What separates a messy weld from a true masterpiece?
I think this quote from the American Welding Society just says it all perfectly. Because this is a manual process, the quality of the final product is all on the person holding the stinger. It's a true craft that's one part science and one part steady-handed artistry.
And here's what that difference looks like. I mean, talk about night and day. On the left, you've got a bad weld. It's full of holes, it's uneven, there are gaps. That joint is weak, plain and simple. It's going to fail. But on the right, that's a quality weld. See how the ripples are even, like a stack of dimes? How it's fused perfectly with the metal on both sides? That's a joint you can build a skyscraper on.
So, let's just quickly run through the big points. We learned that stick welding is an incredibly versatile, totally manual process. The real magic is in that flux covering on the electrode, which does three jobs. It shields, it cleans, and it protects the weld. We also figured out how to crack the code on the side of an electrode, and we saw that a great weld is all about that constant balancing act between current, arc length, and travel speed.
And that kind of leaves us with one last thing to think about. We've seen that stick welding is a true hands-on craft. It takes human judgment, a steady hand, and the ability to adapt on the fly. Things that are really hard to program into a machine. So in a world where everything is becoming more and more automated, it really makes you wonder, what's the future for these critical skills that still need that human touch? Thanks for tuning in.